some basic monomial operations. So this will look very similar to exponent laws because that's essentially what we're going to be using, but there's a little extra that we have to be careful about. So when we're looking at, let's say, this first example, what we need to do is we need to basically split up the question into separate parts. So we need to first of all look at what numbers do we have. So just the coefficients in front, we have just 3 and 5. So part number 1, just multiply those two numbers together. So 3 times 5, that will give you 15. All right, then part number 2, that's going to ask what's happening with your variables. So with your first variable, you have a squared and a to the 4. So then we're going to multiply those like they were actual, like regular multiplication of variables. So it would be a squared times a to the 4. And we know based off our exponent laws, if you have the same base, you add the exponent. So 2 plus 4 will give you 6. So it's 15a to the 6th. All right, let's look at a similar one, but this time involving the division of parts. So again, start off with your coefficients, the numbers in front. Deal with those just separately. What's 9 over 3? Well, 9 over 3 is the same as just 3. So we can start with that. Then you can go, in a sense, letter by letter. So we have an x cubed and an x squared. So we're just looking at x's here. What is x cubed divided by x squared? So using our exponent laws, you do 3 minus 2. Because when you're dividing the same base, you subtract the exponent. And the last part, you'll see that there's basically only a single y there. There's no like y in the denominator. So you can just leave it as is, so y squared. And rewriting this, that will give you 3 to the x. Well, 3 minus 2 gives you just 1. And you don't even have to write the exponent 1. And then y squared will just stay like that. So there is our solution. Let's take a look at one final thing. So what if you have an exponent to a whole bunch of things? So what we had said before in our exponent laws is that if you have an exponent, you have to apply that exponent to all of the different parts. So even though you have a monomial there, you can apply it to each of the separate letters and the number in front. So you're going to have something like 3 to the exponent 2. You have a to the power 4. Well, that's also going to get another exponent to it, which will be 2. And then you have b to the power of 3, and that's also going to get the exponent 2. So you've basically brought that exponent from outside the brackets and put it inside to everything. So what is 3 squared? Well, that's going to be 9. And here we have to remember what our exponent to an exponent rule is. So if you have something to an exponent that is to another exponent, the rule said that you had to multiply those exponents, and that would give you the result. So it's a little bit different than when we were dealing with, let's say, the letter A's up in the first example. So in this case, you'll have a to the 8, because that's 4 times 2. For b, you'll have 3 to the exponent 2. So you multiply those exponents, and you'll get 6. And that's a look at that example.